Okay, great. So, hi everybody. My name is Marina Elliott. As Katie mentioned, I'm actually a Canadian biological anthropologist and archaeologist. And I did my PhD and master's at Simon Fraser University in BC. And as Katie said, I'm now back in Calgary, still doing some research with Simon Fraser, but also teaching at U of C and at Mount Royal. So we're just winding up the semester. So everybody's a little bit crazy. But yeah, before I moved back to Canada in 2020, I had spent the previous 7 years in South Africa working on Homo naledi in the Rising Star Cave. And so that's what I'd like to speak to you about tonight. Some of you may have heard about it in the past. It made big news in 2015, and it was featured in the National Geographic magazine. But in case you haven't heard about it, and there's a lot that's happened since then, tonight I wanted to give you kind of a little recap of how I got involved in the project, and then a little bit about what we've learned since about this interesting new member of the human family. First, though, just to orient you a little bit, there's an area in South Africa known as the Cradle of Humankind. It's about 70 kilometers outside of Johannesburg, and it's been famous for fossil hominin sites like Sterkfontein and Swartkrans since the early 1930s. And it was made a World Heritage Site in 1999 because of the remarkable discoveries made in the area. There we go. Many of the fossil sites in the cradle, and in fact around South Africa in general, are associated with caves, although most of the material in the past was collected from surface rubble blasted out from mining operations. And probably one of the most famous of these is called the Tong Child. This is a 4 to 7-year-old juvenile that was discovered in a limestone quarry in Western South Africa, so not actually right in the cradle. And it was identified as an early hominin called Australopithecus africanus by Raymond Dart in 1924. And for a number of reasons we can talk about later if you want, this one fossil almost single-handedly kicked the discipline of paleoanthropology into high gear and kind of changed the way we look at human evolution. But Homo naledi's story actually started a bit more recently in 2013 when two sport cavers, Rick Hunter and Steve Tucker, entered a cave system called Rising Star, located just on the edge of the cradle. And the pair had actually been recruited by another paleoanthropologist named Lee Berger, who's American, but he's been working in South Africa for many years, and he was responsible for discovering another new species of hominin called Australopithecus sediba in 2008. But having found sediba, Lee thought there might be even more fossils to be found underground. But as he kind of jokes himself, he was no longer physiologically appropriate for caving, so he asked these recreational cavers to start looking out for bones during their outings. And in fact, Rising Star is a really well-known recreational caving area in the cradle, and hundreds of cavers have trained in its passages over the years, with many of the routes having been mapped, as early as the 1980s, and you can see the labyrinth of passages here. One night, though, Rick and Steve were exploring an area off the map and ended up in a small slot of rock. They discovered that it kind of continued down, 12 meters in fact, and led into a series of smaller chambers. In one of the second chambers, they found something quite interesting. And this was a scattering of bones on the floor, some of which looked pretty human-like. So they took these photos to Lee to see if these were the kinds of things that he was looking for. And Lee immediately recognized them as potentially really important. But the cavers had said that the route was really hard to get to, and Lee would probably never make it through the squeezes. So Lee had to figure out how he was going to get these fossils out of the cave. So, of course, he did what any good researcher would do, and he put an ad on Facebook. And I didn't actually see this ad, but I was finishing my PhD in biological anthropology and archaeology at Simon Fraser, and my supervisor sent me this post. As you can see, the requirements were pretty specific, and it all sounded just a bit weird and slightly crazy, so naturally I was in. But one of the reasons that I was so keen was that I'd grown up here in Alberta, and I'd done a lot of hiking and climbing and caving for fun. I've been in Rat's Nest, I've been in a bunch of other places in the Rockies, so I figured I had the necessary physical skills to get into the cave, but I also had the academic skills from my degrees. And I'd actually already excavated in some pretty extreme environments. So first in Siberia with a 5,000-year-old hunter-gatherer mortuary site, and then in Alaska, where we excavated under armed guard. And that was not actually for dangerous people, but for the polar bears. So I really thought that I had a pretty good shot. But as it turned out, almost 60 other people thought they had, that they had the right stuff as well. In the end, 6 of us were chosen, 4 Americans, 1 Australian, and me. And I like to joke that I'm kind of the Canada arm of the group, even though that's now pretty dated and nobody knows what the Canada arm is anymore. But within a month, basically, we were all in South Africa setting up a 60-person camp, and we enlisted the help of numerous volunteer cavers and dozens of scientists, and we ran kilometers of power cables and communication cables into the cave, set up multiple cameras throughout the cave system to monitor the safety, and they constructed a command center on the surface and a science tent to process some of the fossils. Now, it was a major operation whose sole purpose was to recover these bones from this remote underground chamber. And by remote, it's pretty hard to get into. You guys are all familiar with caving and squeezes and all the like, but this fossil chamber is about 200 meters from the nearest entrance, and it's between 25 and 30 meters below the surface. To get there, though, you have to travel through a couple of narrow hallways, which are pretty straightforward because you can still sort of stay on your feet. But then you go down a narrow vertical shaft about 4 meters high, where we have placed a ladder that's sort of in the bottom right-hand corner there. And from there, you enter a section called the Superman crawl, which is called that because you literally have to lie on your stomach. And if you have broad shoulders, you usually have to put one arm up above your head and keep the other one pinned to your side and literally just push through with your toes. From there, you enter an area called the Dragon's Back Chamber, which leads to a large fallen dolomite block called the Dragon's Back. And this is actually a knife ridge of rock, only about 25 centimeters wide, with a 6-meter drop on one side and an 8-meter drop on the other. And at this point, we would rope up, we would wear harnesses and rope up across this section because a fall on either side would be pretty devastating. Then at the top of the Dragon's Back, there's another section called the chute. So there's a sort of a narrow section right before that 12-meter crack that Rick and Steve entered, and that we now call the chute. And it's a 12-meter vertical slot with a number of quite nasty pinch points in it, one of which is 18 centimeters wide. And so you really have to kind of maneuver your body through that section, just kind of feeling with your hands and feet because you can't really look down at this point. But then you drop into what we now call the landing zone, which is the first chamber, and then just through another hallway into the Dinaledi chamber itself. Now, I was the first of the scientists to get into this chamber, and at the time, we actually really thought we were going in to recover just a single skeleton, probably of a known hominin, something like that Australopithecus africanus that I showed you earlier. But when I got down there and actually started shining my headlamp around, I realized that we were dealing with something quite different. So I could see some of the bones that Rick and Steve had taken photos of at the beginning, but there was also a lot more material on the surface than we'd actually originally expected. So our first task was to mark everything on the surface so that we could actually move around the space. And every fossil or fragment was photographed and tagged and bagged and then transported to the surface in plastic containers and also in dry bags. And doing this, we recovered just over 300 fragments in this phase. Then when we actually got down to excavating, we were working, there were 6 of us, but we worked in pairs. There's really only room for sort of 3 people at a time in this space. And there's a large overhang of dolomite right above the area that we were working in. So you basically are working on your hands and knees the whole time. And the cave itself maintains a pretty constant temperature of about 18 degrees Celsius. So that's not uncomfortable, but it's at a very uncomfortable 99% humidity. So the work can be quite sticky. And unlike most other sites in South Africa, the fossil material is not encased in hard breccia. It's not sort of concreted, but it's in soft clay sediment. So we used sort of standard archaeological excavation techniques, mostly toothpicks and paintbrushes and little plastic spoons. And the tight spaces actually prevented us from bringing in and using any normal survey equipment like a theodolite. So for spatial documentation, we used an Arctec white light 3D scanner in addition to photography and hand drawings and the usual sort of documentary procedures. And then, as with the surface material, once we'd excavated the fossils, they were documented, packed in bubble wrap, put in plastic containers, and transported to the surface. In the case of one large skull fragment, we ended up packing it into a cereal bowl that we stole from the kitchen, and it was the only thing that would support the shape of the skull. And then we put that plastic tub into another tub and hand passed it from caver to caver until we reached the surface and got it to the science tent. Once actually at the science tent, the material is cleaned and identified and documented, and then repacked and stored in locked safes on site. And the area that we were in, as you can imagine, is a little bit rural. So in South Africa, that's always a source of concern sometimes. So everything was locked in safes. And the joke around camp after about the third day was that we were going to need another safe and another safe. And so we ran out of room pretty quickly. We then did a second round of excavations in March 2014 with a smaller crew and only 2 excavators, Becca Peixoto from the US and myself. So that was just sort of a more targeted set of excavations that we really wanted to get after some particular material that we hadn't had a chance to get at in 2013. And the process of getting in and out of a cave, as you can imagine, is not so easy and can be a little bit rough on the body. But I think we all felt that it was pretty worth it, because after those 2 short expeditions, we had recovered almost 1,600 fossil fragments. And this is actually one of the largest single assemblages of fossils in Africa, and almost more than any other excavation in the world. And this photo here represents about a third of the material that we recovered from the Dinaledi chamber itself. But of course, getting the bones out of the cave was just the beginning. The next task is actually to identify all this fantastic material. In May 2014, I returned again to South Africa to join the analysis and description teams. And in total, there were almost 40 scientists involved from all over the world. And we were dedicated, and I think we dedicated more than 10,000 man hours to figuring out what we were dealing with all this skeletal material. And that in itself turned out to be a bit surprising. So first, the preservation of the material from the cave was really pretty excellent, especially for paleoanthropological material, as you can see here from these 2 partial skulls that we recovered and reconstructed. So the teeth themselves look almost perfect. And then the demographic profile was actually really cool. In that first assemblage, we had 15 individuals of both males and females, ranging in age from neonates to older adults, and we're now up to about 23 individuals from the Dinaledi chamber. And we had some really complete material, like this beautiful foot, and we have actually 5 that we have partial remains for, so the preservation is really lovely. And this almost complete hand that Becca and I excavated in 2014, we actually found it fully articulated with the fingers sort of curved over the palm, and it's really only missing 1 tiny bone in the wrist, the pisiform. And we have actually parts of 7 other hands in the assemblage, so really remarkable. And we've actually recovered some extremely rare elements, like these tiny ear ossicles, and these were sifted out of the back dirt. Prior to Rising Star, only 2 other such bones existed in the early hominin fossil record. And so now we have more than doubled the sample size with these. So that's really cool too. And then because we have almost every element represented multiple times, we have a pretty good idea of what Homo naledi looked like. And overall, it shows a really interesting mix of features, a very sort of small brain, small cranial capacity, but with some very much more modern looking teeth, and some features that look much more much more modern. The shoulders, for example, are very archaic, so look again much more like extant primates, even actually a bit more like a gibbon. But then as you move down the arms, again, they become much more human-like, except the fingers, again, are very curved, again, much more like modern primates. And then the lower limbs, the pelvis and the legs, again, look much more modern than we were expecting. Long legs and feet that look almost indistinguishable from modern humans. And it's pretty small in body size, averaging about 40 kilos and standing around 140 centimeters tall. And really interestingly, some of Naledi's features appear to be entirely unique to it. So in particular, the shape of the thumb and some aspects of the spine and upper leg. So it seems as though Homo naledi might have been doing something different from other species in terms of its grip and maybe its locomotor behavior. But because we have so many individuals, it was pretty easy to establish that all these unusual features weren't the result of some disease or injury. And from this combination of features, we were pretty confident about designating a new species as well. But as if all of that wasn't enough, the physical context of the material was unusual. As I said, the access was pretty difficult to get to. It's in a very remote part of the cave. But also, those 1,300 specimens that we recovered in 2013, over 1,000 of them came out of a single excavation unit, and that was 80 centimeters by 80 centimeters by 20 centimeters deep. So that's smaller than the size of about an average child's sandbox. And you can imagine the density and concentration of material that we were working with. Then, with the exception of a few modern bird bones and a handful of isolated rodent remains, there were no other large vertebrate species found in the chamber with all those hominin remains. And that's really, really uncommon, especially for a paleoanthropological site. Nor was there any evidence for occupation, no fires, no hearths within the site or anywhere within the rising star system itself, past or present. We also have no evidence for carnivore or scavenging activity on any of the bones. Again, a very unusual circumstance when you're dealing with a natural accumulation. And then the material couldn't have fallen in from above because there's a layer of rock, it's called a capping chert. You guys probably know about that kind of stuff, above the chamber that's unbroken. And we did quite a lot of subsurface exploration and some ground penetrating radar from the surface to try and determine this. Had the geologists sort of going nuts on the surface trying to figure out where this chert existed. So we know that there wasn't a hole above the chamber that stuff could have fallen into, like happens in other areas in South Africa. We also know that the material couldn't have been washed in by something like a river or a flash flood. And this actually comes from the geological evidence in the sediments, as well as the presence of that beautifully articulated hand, because all of those tiny little bones would have been moved or lost if there had been much movement in the sediments after it had been deposited. And obviously the hand had to have come into that space with the soft tissue still on it for all of those pieces to still be there. We also know from the position of the bones that the material didn't enter the chamber all at once in some kind of catastrophe, but that they accumulated over a period of time. We don't really know necessarily how much time that is, but we do know that some material went in with the flesh on the hand, for example, when there was already skeletonized material in the chamber and in the sediments. So without a lot of other options, we basically ran out of ways to explain how all these individuals ended up together in this remote area with no other animals. And it left us with the only reasonable explanation that fit the evidence. And that was that Homo naledi may have been deliberately disposing of its dead in this chamber. Now, that might seem a bit of a difficult conclusion to accept, but it's the only one that made sense given the evidence that we had. But a single example is just a phenomenon. To be truly convincing, it helps to find another example that then starts to show us a pattern. And at the end of 2013, we actually found just that, a second locality of Homo naledi remains in the Rising Star Cave. The second chamber is called the Lesedi chamber, and it's separated from the Dinaledi chamber by more than 140 meters of tunnels. And in fact, you have to go sort of all the way back almost to the surface entrance and then hang a left to get back into the Lesedi chamber. And at the end of 2014, I actually moved to South Africa full-time to work on the Homo naledi site. And my first task was to excavate the material from this new chamber. Now, the access to Lesedi is a tiny bit easier than the access to Dinaledi chamber. But if you can believe it, the working space is quite a bit smaller, with only room for one excavator at a time. And I mostly sort of worked, as you can see in the picture on the left, kind of hunched over on a pinnacle of rock with dolomite walls on either side of me. But again, I really felt that the effort was worth it because we recovered parts of at least 3 more Homo naledi individuals, including this almost complete adult male, which we nicknamed Neo, which means gift in Sesotho, one of the 11 official languages in South Africa. And he really is remarkably well preserved and you know, for paleoanthropological purposes, pretty intact. At the same time, though, we were working hard to date the material from the Dinaledi chamber to try and figure out where it fit into the human family timeline. The ancestral-looking anatomy that I talked about before had originally suggested to some researchers that Homo naledi might be 1 million or possibly more years old. But after multiple analyses using double-blind labs, we actually found that the bones were surprisingly young. And in fact, just a few months ago, we published a refinement of the dates, narrowing down the period in which the remains were deposited even further. So then our question became, how do we explain this mismatch between the anatomy that we've got and these very young dates? Well, we actually know from other examples in the animal kingdom that taxa can remain unchanged for many millennia with modern populations looking almost identical to their ancient ancestors. So it is possible that some kind of similar stabilizing selection was operating with Homo naledi. And in fact, we have other examples within the Homo genus in the form of a species called Homo floresiensis. Some of you may have heard about this. Its nickname is also called the hobbit. It comes from Indonesia, and it's another species with this sort of strange combination of archaic and modern traits, and this really tiny cranial capacity. And it was originally thought to be as young as 17,000 years old, but it's been recently redated to more like 100 to 60,000 years. But that's still very, very modern given the anatomy and the morphology of this species. And in fact, we have another recently announced potential species from the Philippines called Homo luzonensis that also seems to show sort of a combination of archaic looking traits, but existing into more recent times. Unfortunately, there isn't much material attributed to luzonensis yet, so we'll have to wait for more evidence before we can say much more on that one. But collectively, these species are starting to show us a really interesting pattern to human evolution, something more complicated and fascinating than that straight line that it's kind of sometimes visualized to be, and that there's a lot more nuance than maybe previously assumed. But Naledi's dates were also surprising because we know from other sites in Africa that anatomically modern humans were around at the same time and may even have been in the same area. So potentially, it's conceivable that Homo naledi and modern humans could have interacted. Now, we don't actually know what those interactions might have looked like, but it's an intriguing set of questions, particularly since we already know from DNA that modern human groups shared variable ancestry with groups like Neanderthals, Denisovans, and at least 2 other ghost groups that we only know from DNA. So the potential is there. Now, naturally, the recent dates also raise some questions about the South African archaeological record. There isn't a ton of skeletal material associated with the early Middle Stone Age in South Africa, that sort of 300 to 130,000 year area. So it's hard to say who made the stone tools that have been found there. Now, again, this might be surprising, but it's not far off the situation that we have in East Africa, where we already know that there were multiple hominin species on the landscape at the same time, and no smoking gun to say which one was making the stone tools. And for me, these kinds of discoveries make the science much more interesting. And of course, after all we've learned so far, there's still so many more questions. And one of the big ones for Homo naledi was whether or not that concentration and density of material that we found in 2013 was consistent across the chamber floor. And in fact, when we published the material, the first descriptions of the site in 2015, we kind of depicted the floor of the chamber as this consistent bone bed, with the fossils that we collected being just a small sample of what was there. Well, as it turned out, this wasn't quite right. In 2017 and 18, we went back into the Dinaledi chamber with the specific goal of trying to determine the extent of the fossil material in the chamber. And in fact, we actually decided to start below that 12-meter high chute in the landing zone where we thought the bodies might have been coming in. And since it's the highest point of sediments in the chamber, we hypothesized that if the bodies had fallen in or were just even being dumped down the chute instead of being brought all the way in, that there might be material just sort of directly below the chute, and then we would find that it had trickled down into the Dinaledi chamber proper. But what we actually found was a mass of skeletal material right at the top of the sediments, and then sort of a big gap in another group of bones at the bottom, and nothing in between. So that was really not expected. And what was really cool about the material at the top of the slope was that some of it seemed to be articulated. So that's as it would be in life. And there were even some teeth kind of peeking out of the surface at us. And this really made us stop and think about how to get the material out safely while also preserving that important position and orientation of the bones that we thought especially were articulated. Excuse me. In the end, we went kind of old school and encased the material in plaster, the way you've probably seen paleontologists do to remove dinosaur bones. Unfortunately, that whole big mass was too big to get up that narrow chute, so we had to divide it into 3 sections. And we affectionately called them Blob 1, Blob 2, and Blob 3. Blob 1 and Blob 2 were pretty small and manageable, but Blob 3, which held what we thought was that really critical articulated material, was over 60 centimeters long and weighed an uncomfortable 24 kilos. And by the time we put padding around it and a caving bag, we weren't sure Blob 3 was even going to fit up the chute at all. It was like moving, literally like moving another whole body up that chute. But 6 cavers, 2 pulleys, and 2.5 hours later, remember, we're only moving 200 meters, but 2.5 hours later, we managed to get it out of the cave safely. And since they were so nicely protected in those plaster jackets, we actually decided not to crack them open right away, but instead we CT scanned them to look at the contents. Not surprisingly, that Blob 3 turned out to be the most interesting one, and those tantalizing teeth that we'd seen on the surface actually turned out to be a whole set of teeth, most of which were in their proper position, and it appears to be a juvenile. So that's actually super exciting. At the moment, though, the plan is to leave the blobs intact, and we'll try and virtually excavate them using computer software, so that's going to take a little bit of time yet. Further into the Dinaledi chamber, though, we also opened units up on either side of the original 2013 excavation unit, and here we found kind of a dead zone around the original unit where there were no fossils, and then another concentrated feature of dense bone. So you can see that picture on the bottom right there. So instead of that consistent bone bed that we originally thought we had, we appear to have articulated material at the highest point in the system and at the lowest point, but no evidence that the bones were tumbling from one area to the other or piling up against the wall that actually separates the 2 spaces. So this is actually super hard to explain as a natural phenomenon, and there's a lot more work that needs to be done to figure out what's going on, but it certainly doesn't seem like it could be a natural accumulation. So it tends to support this idea that the species was bringing their dead into this space deliberately. Meanwhile, our exploration teams were also working their way into some of the really remote and tiny fissures around the Dinaledi chamber, looking for alternate routes in or for more fossil material. And as you can see, some of these fissures are extremely small and earning them unfortunate nicknames that we can't include in any publications. But as cavers, you guys all know that there are some pretty colorful names when it gets to be tough going, but they're officially known by numbers rather than their more colorful names. But just a few months ago, we published 2 new papers describing some of the material that was recovered from one of these nasty locations. It's actually less horribly known as pandemonium, but it's officially known as UW110. And the material here consists of some fragmented cranial remains and the teeth of a 4 to 6-year-old child, also Homo naledi. And the location is about 10 meters away from where the main Dinaledi assemblage was recovered, and it's also in one of these confined and quite awkward passages. So in total now, we have almost 30 individuals recovered from at least 3 different localities in the cave system, from areas that share similarities in terms of their depositional environment and in terms of their sort of awkward and nasty context. And in fact, the fact that they all contain just one species, we've only found Homo naledi in this cave, and 8 years later, we still don't have a better hypothesis than the one of deliberate deposition. So all of this is really pretty interesting and pretty exciting for geeks like me, and it is sometimes challenging to kind of fit in with what we know about the origins of humanity, but it really reinforces that we still have a lot to learn and that there's a lot more going on in South Africa than we ever really imagined, and that's super exciting. And it proves that our family tree is a lot bushier and probably more complex than we ever thought. And instead of a tree, it might actually be better to imagine it as a river delta with kind of multiple streams flowing down from a common source, sometimes diverting and drying out, so going extinct, or sometimes joining another stream, when species interbreed, to finally make their way down into one big pool at the end. And at the moment, that big pool is the more than 7 billion humans that we have on the planet today in all our beautiful variety. But for me personally, this discovery also emphasizes that exploration is not dead. I was definitely one of those kids that loved reading about daring explorers and explorations, but I kind of thought that that great age of exploration was over and that there wasn't more to find. But it's not true. Homo naledi was discovered in a well-known cave in an area that was already famous for its fossils and in an area that many people had been in before. They just hadn't seen the material with the right lenses or the right eyes. So there's no reason to think that there aren't more amazing things to find, maybe even in our own backyards. And on that note, when I returned to Canada in 2020, I started thinking about what amazing discoveries might be waiting for us on this continent. And we think we know a lot about the prehistory of North America, but if Homo naledi has taught me anything, it's that there's always more to discover. So one of the other things that I've been working on since I've been here is applying my experiences in South Africa to the North American context by revisiting the evidence for human activity in caves on this continent and compiling what we know, what we don't know, and trying to find ways to apply new technologies to the question of sort of when and how humans came to dominate this part of the planet. So to do so, I've teamed up with colleagues from SFU, and we've applied for some grants, and we've enlisted people like the Alberta Speleological Society and some other organizations, and we're working to build a group of people who are interested in and active in cave exploration and scientific cave research, and actually trying to not only build this database of baseline information, but also start targeting some areas that we think might have a high potential for giving us some interesting information. And in fact, we've actually been pretty successful already. So our database, so far we've collected data on over 850 cave sites in Alberta, BC, the Yukon, the Northwest Territories, and Alaska. And even more excitingly, we've actually identified a cave with previously unknown pictographs in it. And this site, which, as you guys can imagine, we're not really sharing the name or location of yet, although some of you may know about it. So we've discovered this site that has this previously undocumented pictograph material in it, and we're working to actually get permission to do some more research on it and document it properly, and then publish on that. And last year, my colleague Mark Collard from Simon Fraser and I had a chance to visit the site with the cavers that had found it and actually, assess it. And it looks to be legitimate. So we're going to go ahead and try to apply for permission to do some documentation of that site. So it's going to be really exciting, hopefully in the next year or so, if we can get some funding and some time. But we'll see how that goes. But overall, one of the reasons I think that the projects like Rising Star, and in fact this new project, which we've called Cave West, are so important is that they really help us understand who we are as humans. It's pretty important. Humans are pretty interested in their past. Everyone is sort of curious about their family history, why they are the way they are, where they come from. So projects like these are really about tracing our human family history in deeper time and across the whole globe. And in doing so, it gives us an opportunity to reflect on what it means to be human, what we share as a species, and what we want our future to look like. And maybe in these slightly trying times, it might not be so bad to focus a bit more on our commonalities rather than our differences. So we actually have quite a lot more to learn about our collective past, and I truly think it's a pretty exciting time to be involved in the process. So it's certainly not a dead science, that's for sure. And I think there's a lot more to be learned, both in early hominin research and a lot more to be done in our own backyards here in Alberta. So with that, I think maybe I'll finish up and I can answer any questions if anyone has them.
Thanks for presenting there, Marina. I guess I'm just wondering about the humidity change from coming out of the cave and then going into the safes.
Oh, we lost Colin. Do I have everybody else? Yes,
Can
I'm
you hear
still
me?
here, Katie.
Okay. Colin, are you there?
Yep, I got you. Can you hear me?
Yeah. Yeah, sorry, you got cut. You were asking about humidity and then it seemed to get cut off.
Yeah, I guess I just wonder, did you do anything special for the humidity from coming out of the cave and then going into the safe? Was it humidity controlled or anything like that?
Oh, I'm just like, we might have actually lost Marina.
Sorry about
Oh,
that.
there she is.
Sorry, happened to kill everything when I tried to stop sharing my screen. So I'm sorry. The question was about the humidity change between being in the cave and then bringing them out into the lab. Was that correct?
Yeah, correct. Yeah, just wondering if you had some control measures in place.
Oh yes, yeah. So the material, as I said, when we were excavating it, the sediments, they're not super saturated, so it's not mud. It's sort of dampish clay. And so the bones are quite friable when they first come out. So when we packed them, we were really careful to pack them very carefully. And then when they went into the lab at the university, they were unpacked and they were allowed to dry very slowly under controlled conditions. So they weren't allowed to just kind of explode, although some of them did that. It's just sort of unavoidable. But we tried to keep them drying as slowly as possible. Then once they were dried, then they were stabilized with various chemicals and then reconstructed. So yeah, but the preservation is actually remarkably good, and we didn't lose very much at all in that transfer.
In
Okay,
one of
thanks.
the earliest early diagrams in the presentation, you had the water level marked in the map, but in your description of the deposition of the humans, it doesn't seem like the water was impacting.
No, the water table, there might have been a reference to that in one of the early photos. I can't remember. No, the water table is about 2 meters below where we're working. And the geologists think that it may have been like sort of a seep inundation periodically, but over a very slow amount of time. And it never was sort of flash flooded in there. So as I said, the clay is slightly damp, but we don't have any standing water in the cave.
We don't really have any 18 degrees Celsius caves in Alberta that I've found or know of. Do we have any records or trends of where human remains would be likely to be found in North American caves? Like from a temperature or depth or any type of...
Yeah. Yeah, it's a great question. That the Rockies ideally should be better for preservation. The sort of the humidity and temperature in South Africa is actually very destructive to skeletal material. And when I was working in other places like in Siberia and Alaska, where you've got quite a bit drier conditions and colder conditions, that's much better for preservation of skeletal material. So ideally, the caves in Alberta should actually be better. And so, the idea is, again, once you're, if you're trying to understand people moving in from, say, Alaska or through the ice-free corridor, and I don't even think necessarily that we have to have an ice-free corridor. People have been moving across ice surfaces for a long time and are pretty good at that, and in fact do it deliberately sometimes to avoid having to cross large bodies of water. Then we might actually be better off looking at areas that have refugia all the way along the corridor that may have been iced during the last glacial maximum, but like the corridor is iced, but these refugia still might be uniced or at least viable. So we'll have to see what happens. Depth-wise, we don't know. And again, some of it is speculative, but if any of you know about places like Bluefish Cave up in the Yukon, they've found some very early dates there, and there's starting to be more and more research done further south in the US and also in Mexico that are potentially finding evidence for human occupation much earlier than we ever expected, like sort of 30,000 years ago. So they had to have gotten there somehow, and So we'll just have to see. I mean, you can't find if you don't look. And I think I saw a question in the chat here. Okay, Jim from Vancouver, Port Alberni. Yeah, we have a cave here that has pictograph and 1,000. Yep, yep. Yes. Well, yes, I would be absolutely. So it's a sort of technical question about some caves in Vancouver Island, and I'm totally happy to start talking about what you guys know about caves that you are aware of, and ways that we can share information. That's kind of part of the point of this Cave West project, is that we're trying to bring a whole lot of stakeholders into a conversation. We know it's not going to be easy because everybody has their differences, I guess I could say, but we've had quite a lot of really positive response. We've had positive response from caving groups like you guys. We have a partnership sort of formalized now with a First Nations organization called Sea Alaska Heritage, which controls a lot of the Alaskan sort of cave areas, and so they're very willing and interested in collaborating with us. And we're slowly, we've got some buy-in from the International Caving Association. We've got Bat Caver is involved, at least peripherally in some cases. So we're really trying to pull in as many people as we can. First Nation organization, cavers, cultural and natural heritage managers. And really what we're trying to do is get everybody to the table and start talking about ways that we could make this work. We don't want to necessarily dictate the terms right from the get-go, but we want to start having that conversation. So I'm certainly open to having that conversation with you guys as well. And I have another question. In some of these photos, it looked like the skull bone was depressed into a mold. Was that computerized or standard physical? So the question is, some of the photos, it looked like the skull bone was depressed into a mold. Was that computerized or a standard physical end result for long-term presentation? I think it was just the one transportation thing. So the one piece of skull that we had to get out of the cave, we did actually put into a bowl and then move out. But once they've been chemically stabilized and reconstructed, they're actually surprisingly sturdy. So then we don't support them after that. They're just they're on their own in their. I had to make cases for them, but they are on their own.
In one of the pictures near the end, you had a skull that looked pretty black, and then there's just a like the forehead and another couple pieces that were pink. Is that maybe what Clinton's talking about?
Yeah.
Well, okay, let me see if I can find that.
I think it was in maybe in your 2017 excavation.
Okay, it might just be that's probably Neo, the more complete skull. That might be the one. So the black is often manganese staining. That's quite common in the rising star system. But we also have the clays themselves are quite reddish. And so it might just be that there was still some reddish clay clinging to it. I'm just not sure maybe what picture that was referring to. But it's, the darkness might also just be the photographic effect. Hard to say. The fossils themselves turn out, once they're cleaned and prepped, to be kind of sort of a darkish red brown. And that's just from the staining of the sediments.
I'll throw a question at you if you have a moment here.
Of course.
You've been in Rat's Nest. Have you been down Coyote?
I have not. Where is Coyote?
Coyote's descent is down the wild side a little bit, and then there's a full coyote skeleton that is like a decent ways in there.
Yep.
And it's sort of drawn the implication that this thing might have suffered through the dark for an incredible amount of time before succumbing. Yep. Or sort of drawing the implication that there might be a second entrance that has since closed. Like, given the distance that you had into your cave there and the consistent amount of bodies in it, you said with that chert layer, it has sort of ruled out the prospect of an additional entrance.
Yeah, I mean, we've done some pretty exhaustive both surface and subsurface exploration to try and figure out whether there was another possible entrance. And in particular, it's because in South Africa, a lot of the fossil accumulations come in via what they call death traps or sinkholes. So they have, a tree above a sinkhole, and animals, particularly leopards, taking prey up into the trees, and then as they disarticulate, they just drop down into these sinkholes and accumulate that way. And so that's very common in South Africa. When we started looking at Rising Star, we thought, okay, well, is this a possibility? And so we really tried very hard to find a couple of other entrances. There's one crack about 5 meters away from the Dinaledi chamber itself that could have been an entrance, except that it filled with speleothem, so filled with flowstone somewhere around 600,000 years, and that flowstone is still intact. So at 300,000 years, it was already sealed off when the Homo naledi material came in. And so we really have not been able to find another potential entrance for this material at all. And we've been trying for 8 years.
And that, like you said, they're about like 1.5 meters tall at that point. So they might have been a little bit easier time getting over the dragon spine than we would.
Well, yes. I mean, they are quite a bit smaller than we are. A lot of people have speculated about, whether they would have needed fire or, something like that. But I was doing some research just towards the end of my time in South Africa that I haven't been able to finish yet, about baboon occupation of caves in the southern part of South Africa in the Cape region. And we have documentary evidence. We have film and photography of baboons going down about a 10-meter sinkhole and then moving in and out of properly the dark zone. They're moving in and out of a 200-meter dark zone area, and then coming back out and climbing up this sinkhole and leaving again. And they're taking babies in there, and they're sleeping in there, and they're doing other things in there that primates like to do, but they're occupying these spaces, and they're going quite far into the dark zone and not getting lost. So a lot of the footage shows them doing it by feel and obviously by scent. And we have some great footage of a young baboon who's sort of got one hand on its mother's flank as she's moving through this space, and he obviously is just feeling where she is, but then he lets go at one point and falls off a little ledge. And sort of makes a hue and a cry. And I mean, he eventually gets back up to where she is, but they're literally feeling or smelling their way through the systems, but they're doing it regularly and purposefully. So I don't think that fire was necessary for Homo naledi to be moving in and out of its caves. I think we, as modern humans, just have a bigger obsession with how much light we need to go places. So. And then there's
one quick question again.
Yeah.
I think in the spirit of bringing all hands to the table here and in good faith, it is more than reasonable in the caving community to share with us what are the names of maybe UW 109 and 111, because that sounds hilarious.
Well, yes. So, I mean, they're not even that bad. It's just, academics are a very delicate bunch. Sorry. So there's Hades, there's Hellhole, there's Pandemonium, there's Limbo. And so they got all worked up. I mean, they're not even that bad. It's not like we're calling it, the shit box, where there's other ones in the cave that are like that. And another one called Toilet Bowl. But the academic team members, just felt that there was too much of a religious connotation. So they're not even that bad. And I know lots of much, much worse cave names. So as do you guys. So they're not even that bad. It's just, yeah. Publications tend to be kind of funny about that kind of stuff. So there's another question in the chat. Have any Homo naledi remains been found at other locations? Awesome question. No, not so far. But one of the interesting problems with fossil hominins in particular is that a lot of material sort of gets discovered and they find, one tooth, or they find a part of a long bone, and it goes into a collection and may never get looked at again, or it's just assumed to be one species because that species has been found in that particular location. So I think it would definitely be worth re-examining some of the existing collections for material that might be Homo naledi in those areas. I mean, we have somewhere in the range of 14 other sites in the Cradle of Humankind that have hominin material. Most of that, is things like Australopithecus africanus and Australopithecus sediba, Paranthropus, things like that. But a lot of the fragmentary material might be worth re-examining again. All righty. Any other questions? All good.
Okay, I'm sort of surprised, but what was the oldest of the 30 individuals? Is there an approximate age of the oldest individual?
Well, all we can really say is that they were old individuals in the sense that their teeth were worn down almost to the gums. So, there was a lot of attrition, and that's about all we can say. We don't really know when we're dealing with non-human species what an old individual would look like. Is that 40 years? Is that 30 years? Is that 100 years? But we know that they were old enough and around long enough that they wore their teeth down right to the gums. So those are old individuals. Yeah. And then another question, if human remains are found, is it possible to date that specific bone or only from the material around it? No, we actually did direct dating on the material itself. So there are a bunch of different ways that you can date some of the material around it. The big problem with a lot of hominin material is that any dating method tends to be destructive. So a lot of paleoanthropologists are very reluctant to directly date the material because they've got so little of it to begin with. But because we had this sort of bounty of material, we were prepared to sacrifice a couple of teeth, basically. And teeth are really great for direct dating. So we used a uranium thorium method and a bunch of other methods. Some we dated on the speleothems as well. So we were trying to correlate both the material and the substrate around the material itself, and then actually directly date the materials. So we were very lucky. And so we were able to get dates on the actual material themselves, but that's not always the case in paleoanthropology. And specifically when material is brecciated, when it's already like properly fossilized and turned to stone, that can be next to impossible to do. So, and then let's see, could two remains be separated as erectus versus naledi from bone dating? No, well, you could, I suppose, but you tend to separate species based on their morphology. So particularly with Homo naledi, because we have so many individuals and so much material, we have a really, really good idea of what they look like, and they're very, very different from erectus. There's no question, although right at the very beginning, we had a couple of researchers say, well, it's just another erectus, but they say that about every species that is around. They want basically everything to be Homo erectus. And it's simply too different for it to be erectus. So, yeah, great question though. Okay.
And there's no possibility of them going in there for ritualistic purposes. A little giggle bush in there and talk to the shaman or anything like that.
Well, the fact that they were taking their dead into this space deliberately, of course, brings up all sorts of connotations about what that means cognitively or spiritually or whatever. I personally tend not to use the word burial when I'm talking about the Homo naledi material, in part because they're clearly not human, but also because it tends to raise images in people's heads of like nicely, neatly laid out bodies and sort of clear burials like that. And that's not what we've got. We've got a lot of commingled remains. They are very fragmented, but that happens a lot in modern human mortuary deposition contexts as well. So there's a lot of ways in which even modern humans treat their dead, and that ranges from everything from what they call sort of funerary caching, which is simply to sort of stash a body somewhere, all the way up to very elaborate funeral rites. And so the fact that Homo naledi is maybe engaging in something that's sort of on the spectrum of that is super interesting, particularly because it's not human, and we kind of associate a certain cognitive level with humans. But I think it definitely isn't a black and white thing. It's more of a spectrum. We used to think that only humans were the ones that made tools until we found out that all kinds of other species did so too. Then we kind of had to move the goalposts and say, oh, well, no, it's actually, let's see, culture, that's what makes us human. And then we discovered that other species have elements of that too, in terms of things like, language, and communication abilities that we didn't realize, and ways in which they do things. And so then we kind of keep having to move the goalpost as to what really constitutes human. And really, I think what we should do is accept the fact that we're part of a spectrum rather than completely off on one end.
Okay, and was there any knowledge of like the weather at that time? Like, there's no real accurate.
Yep. There's actually quite a lot of pretty good paleo-environmental evidence. So open savanna-ish. They sort of consider it mixed forest and open savanna. So it's not too dissimilar, actually, from what South Africa is like now. At least that's what they think. And at 300,000 years. The actual landscape hasn't had a chance to change a tremendous amount. It's not like we're talking, 5, 6, 7 million years, which is the situation they have in East Africa when they're trying to deal with some of these species as well. So yeah, from the paleo-environmental evidence, it seems like it's not too dissimilar, a mixed savanna.
Okay, great, thanks.
Welcome. Yeah, and I'm definitely open to to talking more about caves, about caving possibilities. I don't get to cave as much as I would love to these days, but yeah, I'm certainly happy to start talking about ways to share information, ways to try and work on some of these ideas. You guys are the ones that are out there and under there, as it were. So when you see stuff, and it's not easy, these, particularly Rising Star, that cave, that chamber, in fact, people had been in before. We know because there were some cavers' tells in there. It hadn't been, it wasn't sort of on the radar for the recreational cavers generally, but we do know that cavers had been in there, and they simply hadn't seen it for what that material was. So, if you see something, say something, as they say. You see something of interest, take some photos. Don't move it around. But I'm happy to look at any material that you guys happen to find, or continue the conversation whenever you want to do that. So thank you very much for giving me the opportunity to talk to you guys tonight.
That was really interesting, Marina. Yeah, thank you so much. Would
Great.
you be interested in pictures of rodents or like other bones that we came across, or you're mostly interested in kind of human activity, maybe cave arts or that
Yeah,
kind
you
of?
know what? I'm open to a lot of things. One of the things I think I've realized in doing some of the literature searches that we started doing with Cave West is that even a lot of the paleofauna stuff hasn't actually been revisited recently a lot of the time. And there's some caves where, in the 70s, there's a lot of people that did a lot of research back then, and looked at paleofauna, and they were looking at them from a very different perspective, and brought up stuff, and they're like, oh well, yeah, so there was a stone tool among all this paleofauna, but we're sure it was intrusive. Well, maybe we need to actually look at that more carefully. Maybe we need to actually figure out what layer that was in, maybe look at that material again. And so yeah, I'm open to anything, because if you've got fauna, chances are people aren't far behind, right? So particularly if you're looking at these refugia, and we're thinking about people sort of traveling across these nunatak through the corridor, whether it was iced or not, if there are faunal remains there, it's possible that there might be human activity, evidence of human activity as well. And we're starting to get some super cool ways of kind of seeing human activity without seeing the humans. There's environmental DNA now and sediment DNA that can actually can identify species, that the sort of the evidence of species without there being any actual bones, and it's just from the the detritus that we leave behind, in terms of skin and hair and all kinds of other things. So the environmental DNA, I think, is a really cool way to kind of see the potential of activity without actually having any bone, and it's actually minimally invasive as well, which is also quite nice.